Okay, I went live. I'm gonna ask the troll box if they can hear me. Hey, people in the chat, can you hear me? No response. Give me 1 second, guys.
Yeah, the video just switched over to the grid.
Okay, cool. Maybe it's just delayed.
That's an
Okay,
affirmative.
cool.
I think they can hear you.
Yeah, they can hear me. Great. And y'all can hear everyone else on the call too, right? Chat people. Okay. Let's get started. Everyone has the agenda. Let me pull it up. Okay, cool. So we'll do things, the normal two things, do client updates and then research updates, and then get into the stuff for this week. Who wants to start on client updates? How about Harmony?
Previous 2 weeks, we've been working on block processing and block proposer. We have a solo node so far, so it means that it's able to propose blocks and process them. Everything is stored on disk, so the state is preserved between restarts. But for now, it has placeholders for state transition and for fork choice rule. Yep, and the next steps we are going to work on is our state transition and attestation. So what I'm personally doing now is trying to understand the state transition and the things that happens around it, because I'm not fond of the design of state that is suggested in the POC, and maybe next week I'll try to outline something, and so we can discuss it. For example, I think that it's pretty straightforward to use Merkle tree to store validator set and so forth. But to make this outline, I need some time to understand everything that is happening around state transition. So that's where we are.
Great, thank you. Who's next?
Hey, Danny. We can go next at Prismatic Labs. So we basically finished a bunch of the different PRs that were aligning our repo with the latest 2.1 spec. Finished all the processing attestation system. We created basically the entire infrastructure for applying the fork choice rule and updating the head. So we process incoming blocks. We store them, and then we apply a fork choice rule, and we basically keep an in-memory kind of cache of the latest process block of the unprocessed block hashes, and just go through them and update the head when we receive a new block. At the moment, we're basically wrapping up initial chain sync. So I'm getting two nodes to actually one that advances the chain, another one that starts from scratch to get up to the same height, or at least the same slot. And then we are basically working right now on the whole proposer tester interactions to make sure that once a proposer is assigned on a slot, it's able to receive attestations via P2P from attesters. And right now, we're thinking about how we're going to do that. We're probably just going to have one big shard as the network, and essentially just get the proposer responsibility fully implemented. That's basically it.
Cool. And by one big shard, you mean in terms of the P2P layer?
Yeah, for the validators interacting with each other.
Gotcha.
Sorry, guys, a quick question. Do you use the same state structure that is described in POC in the spec?
Yes, we are. We try to be as aligned with the spec as we can.
Okay, I see.
Cool, thank you. How about somebody from Lodestar?
So on our end, progress has been slow and steady. I've been quite busy at work. We're starting to implement the state transition functions and trying to understand everything around that. Also trying to get the Gossip Swap implementation started. And I also have several questions regarding the random beacon implementations and community selection that we'll go into later. But in terms of updates, that's it.
Cool. Status, Nimbus?
Yes, so we finished multi-signature BLS implementation. And now I've also implemented like 80% of the per block processing. What is left is what is in to-do in the Casper sharding spec. And while waiting for this to-do, I've started to implement the Ghost RPG, no IMD protocol. So, and I provided some feedback to the testing procedure so that it's best for us in the future. BLS multi-signature now in NIM. So if needed, we can also export it as a C library, for example.
Cool. And curious, are you using like a common test infrastructure or test cases from the Rust implementation?
So this is a kind of, it's a bit tricky because we didn't find like serialization test vectors to compare to. So hopefully we can agree on some. I can share the notes on the implementation because so that everyone agrees on how to serialize stuff.
Right. Yeah. As we have more implementations of this curve, I think we're going to definitely need to come around to a standard. So that's good. Great. Thanks. How about Pegasus?
Yes. So on our side, we've been working on onboarding. As you know, we are hiring and we have new people, and new people will be arriving next month as well. And we started to look in details at Casper, including its last version. And we're going to formalize all this, and likely we'll have some questions or feedback next week or the week after. And that's it for us.
Cool. Thanks. How about Lighthouse?
Yeah, we've been working to kind of bootstrap the project and get some team resources aligned. We've also been working on some research for P2P serialization. We'll talk about later. We've been eyeing out the state transition stuff pretty hard, just trying to figure out, what the motivations behind that and if it's efficient. And next up, I think the next thing for us is just to start pushing blocks around the network. We're just going to pick a serialization format and just run with it for now. That's it for us.
Cool. Thank you. Did I miss any of the client teams? I don't think so. Let's move towards research. We can start with, is there any updates from the EWASM team?
Yeah, if you can hear me. So we have in the last 3 weeks worked really hard on the testnet we are trying to launch, and that's going really well. And then the next step is that we would like to, it's kind of like a project between the EWASM/Ethereum.js team. We would like to, in the next 2 months, spend some time on do some kind of simulation of execution engine on sharding, where we take the lower layer as a black box. So all the block ordering, anything coming in, that's just a given. And we are trying to do some kind of execution engine simulation on top of that, which may be EWASM, maybe just EVM for the time being, but that's like the next step.
Cool. Sounds good. Any other? I know there's plenty of research updates. I know there's work on P2P. Justin's here with us as well. Does anybody want to give an update?
Hello. On the sharding P2P POC, last week we did the content validation with the validator in Gossip, and we also introduced the communication between Python and Go. So the contents can be sent from Go to Python and validated, and the result can be written back to the Go. And also we can send comments from Python to Go, and they are done through the gRPC, and it can be changed into the other mechanisms like the pipe or other IPC in the future. And we also used another tracer checker and added more tracing. And our to-do is in the next week, and then in the next 2 weeks we will survey more about the connection manager in Gossip, and we'll try to introduce the reputation system, and we'll survey the simulator for Gossip. And that's our update. Thank you.
Great, thank you. Yannick, do you have anything from your side of the simulations?
Not really, just general progress, I'd say. I finished implementation of Gossip, and also of this push-pull protocol, which I described in an ETH research post a couple of weeks ago, I think. But no real results yet. I'm about to limit the bandwidth of all nodes and implement and actually give packets a size so that I can measure propagation times and not only hop counts. And then I should get, I hope to have some results in 2 weeks next call.
Excellent. Justin, anything on your front?
Yes. So I've been, I've basically continued doing research on the VDF and the randomness beacon. So I think last time I joined was actually a month ago, and that was possibly before the VDF day in Stanford, where we invited a bunch of VDF experts. Generally, I'd say this event went very well. Some new results were found during that day just by having different people in the room and sharing our open problems. In particular, we have a new way of aggregating the proofs of VDFs for the construction that we're looking into, called by Benjamin Wesolowski. So you can take 2 VDF proofs with different inputs and aggregate them into single proof. That's very nice. The other thing which was nice is there's a new way of doing watermarking, and by watermarking I mean tagging the proof to a specific public key, so that you can do incentivization and give a reward to a specific key. Another thing that happened during that event is that Dan Bonnet told me and encouraged me to look into the idea of a ceremony to build the RSA modulus. So in a similar way that Zcash had this trusted setup and a ceremony where they had, I think, over 100 participants, and if you have at least one participant that acts honestly, then the whole thing is secure. So I will be looking into the viability of this approach for RSA. And so the idea is you have a few hundred participants, and if at least one of them acts honestly, the end result is a 2000-bit RSA modulus for which no one knows the factorization. And it's important that no one knows this factorization so that the VDF scheme that we're looking into is secure. I guess another thing that happened during that day is that we had people from IPFS and Chia come in. It's looking like IPFS more and more wants to have a random beacon, just like Ethereum, for their blockchain, and they're looking at the same VDF that we are. So it's looking more and more likely that we will collaborate with them, which is good because we want to build a VDF ASIC, and those can be quite expensive if you use state-of-the-art process technologies. So collaborating there means we can collaborate financially and also in terms of engineering resources. One of the things that I guess, one of the rabbit holes that is we've gone down pretty far is an approach to build RSA moduli trustlessly. So the idea basically is that if you pick a 4,000-bit number, let's say, at random, and you make sure that it has no small prime factorizations, otherwise you trash it and you pick another random number, 4,000-bit random number, then with some reasonably high probability, something like 60 or 70%, this random number will be safe to use as an RSA modulus. And what I mean by safe to use is that there is a 2,000-bit component of this random number, which is unfactorizable. So is the product of at least two large enough primes, so they cannot be factored. And so if we pick enough of these random numbers, then with very high probability, none of them will be completely factorizable. And so long as they're not completely factorizable, the scheme is secure. So that gives us a nice way of having a trustless setup for the VDF. The main downside, sorry?
Oh, I was gonna say, and so in that case, do you have to run multiple VDFs at once?
Yes, exactly. So basically, your high-level VDF is made out of these mini VDFs which are run in parallel. And for what you do is that you concatenate the outputs and you concatenate the proofs, and each proof must verify at the same time. The main downside here is that your proof sizes and your outputs are not optimal in terms of size. So the output and the proof per VDF output would be on the order of 50 kilobits. So that's about 8 kilobytes. So that is totally workable, but it's slightly suboptimal. And the other worry is that we need quite a few of these moduli, on the order of 10 or 20. And so if we were to build an ASIC, we might have actually to have several ASICs on the same board, and that might start consuming lots of power, which might not scale very well. But this is still part of the feasibility study that I'm doing right now.
Right, and so it doesn't scale poorly in the sense that the whole world's going to start running them and use tons and tons of energy, but it doesn't scale well in the sense that it's hard for a hobbyist or altruistic participant to just get a setup and run.
Right, exactly. So right now we're looking, if we want to build a totally optimal 4,000-bit multiplier, modular multiplier, we're looking at roughly on the order of 10 watts. So if you were to have 10 of them, or that's 100 watts, which is less than some graphics cards. So it's definitely small amounts of power. But my hope initially was that we could have this VDF ASIC be runnable on a USB stick that you can just plug into your computer. But it's looking more like it would be like a graphics card that you'd plug into a desktop computer. If we want to get this low advantage between the hardware that we deliver and what can be built with with unlimited amounts of money. So the other piece of research that I've been doing is basically looking into the modular multiplication algorithms, which is the basis for the VDF that we're looking into. And it turns out that this is a pretty long and rich line of research. It might seem innocuous, but it's actually non-trivial to find the optimal parallel time algorithm. And over the years, there's been various approaches, Montgomery, Barrett, sums of residues. But there's this one specific team in Australia, that's actually a research lab, part of the engineering department of one of the universities, that are looking into so-called residue number system. And that's kind of nice, because the basic idea is that you can take your 4,000-bit modulus, and you can, in a way, break it down into many smaller moduli. And it means that when you're doing the multiplications and the additions, you don't have these long carry chains, which makes everything complicated. So instead, you work with smaller bit width multiplications, and that's kind of nice. So I'm at the early stage of approaching this research lab, but they, from the initial discussions I've had, they seem quite keen to collaborate. So that's nice. And then another, sorry.
Oh, so as you dug into this VDF research, are you becoming more or less confident in the approach?
It varies from day to day. I'd say in the last few days I've become more confident, and there's lots of sub problems to resolve, and I think I'm confident on the cryptoeconomics, how to build a randomness beacon from a VDF. I'm also confident on instantiating a specific VDF, the Wysolowski construction, and finding a suitable setup, which is either trustless or trusted, or we could combine the various setups. What was the biggest point of uncertainty is basically the ASIC. What kind of budget do we need, and is it actually possible to build an ASIC which is close to optimal? And a big part of that question was, can we use exotic processes that are different from CMOS silicon to instantiate these ASICs? So one that's quite famous is called gallium arsenide, which is a type of semiconductor for which you can build these high frequency transistors. And then another one which is more available commercially, and it is used more and more, is called silicon germanium. And for both of these, it looks like even if you had unlimited amounts of money, it would not work. And part of the reason is that the complexity of the ASIC, in terms of number of gates, and would be so high that your power budget would go through the roof, and there's no way you can feed enough power to the ASIC. So in a way, it is good news that we can kind of hopefully rule out these exotic processes, so that we can focus on what's available mainstream, which is the CMOS silicon. And so now we're looking into, okay, can we actually instantiate it on a CMOS silicon chip? And it looks like the answer is yes. But we're carefully looking into routing considerations and die area considerations and power considerations and stuff like that. And we're also looking into the various process technologies like 28 nanometer, 20 nanometer, 16, etc. It looks like one of the most state-of-the-art process technologies that we could shoot for is 16 nanometer by TSMC. So that's one of the processes we're looking into. the other one that we're looking into is 28 nanometer by Global Foundries. But yeah, I think overall it's too early to tell, but I'd say there's a high chance that the project can be done successfully. I'd say maybe slightly more than 50% chance. In terms of the amount of money that will have to be spent, it's still unclear, but I think 10 million or 20 million or maybe 30 million is kind of the ballpark area. And so this is why, you know, the collaborations are so important. And in addition to IPFS and Chia that are looking to do the same thing as us, there's also a new project that I learned about called Solana, and they have this proof of history, and it's, you know, the whole thing is built around the VDF. So, I mean, they don't have the kinds of budget that IPFS and Ethereum have, but at least they have the will to see it happen, and they seem to have a very good team of engineers behind it. So potential collaboration there.
Cool. Thank you. I think Paul and his team have done some work on some research into the P2P serialization format. If Paul wants to give us an update.
Yeah, sure. So we ended up kind of benching several serialization formats. We looked at Captain Proto, flat buffers, message pack, protobuf, simple serialized by Vitalik, and also Python Pickle, just because it was easy. We ended up getting sizes for all of these to compare, you know, what their kind of on-wire size is. We started on timing, we didn't get anything, but we did come a lot closer to a conclusion. So in terms of looking at the like on-wire size of an attestation record and a block between all of these formats, I think it's simple serialized pretty much wins, hands down always. Except for Pickle, which is like crazy small, but you know, no one really wants to use Pickle for P2P messaging. So yeah, simple serialized is always the smallest. I guess that's really not surprising because it gets to make all these assumptions about schema. So we've been thinking about like what benefits you might actually get from using like Captain Proto or something. One of the things that we keep coming back to is that you're probably going to want to hash. You're going to want to hash, like if you get a message off the network, you're probably going to want to hash it pretty quickly. At least whatever you do, you're going to hash it. So we've been talking before about like, you know, these two different serialization formats. One is for consensus style stuff. So, you know, when you hash it, it always needs to be, you know, the same order of bytes. But if you're pushing around the network, it doesn't have to be. So we're kind of thinking that if you have this different byte ordering on the network and then you have to get it, then you have to move it into the hashing format and then hash it, you've probably lost any benefits you got from having that other P2P type. So given that the requirements we have for writing our own serializer is pretty small, like we only really have to push like a handful of objects around the network at this time, just blocks and attestation records, I believe. And also that even if we do find like another third-party package that does do deterministic serialization, that if they do happen to update in the future, it's just going to be a real pain in the ass because, to use the French, you're going to have to like have clients handle that. You know, like you pull something out of your database and then serialize into the new format and push it out, give it to someone. They're going to have to like know these two different formats. So we're just thinking that it's kind of difficult. So from our perspective, we'd say stick with something like simple serialized. We're going to just play around with it for the next couple of weeks, see if we can make it faster. Otherwise, I think we'd probably go with that. I'd be keen to hear anyone's thoughts.
Paul, a quick question. Did you compare it to RLP?
No, we didn't compare it to RLP. That's a good one.
And is this the simple serialized in the current Python repo?
Yeah, that's right.
Got it.
Not the one in the Eth research repo.
Yeah. I mean, that sounds like reasonable arguments for me to move in the direction of simple serialize. Does anybody have any thoughts on it right now, or do you want to take it offline? Cool, no thoughts right now. Thanks for the work. I'm gonna dig into it a little bit offline. Okay, the next thing on the agenda is this beacon chain testing lang. We've gone back and forth a little bit on a prismatic issue, talking about some of the pros and cons of this format proposed by Vitalik versus a more structured kind of like JSON-esque format or protobuf format. I think that I last looked before we got on this call, Vitalik was of the mind that the easily writable, although maybe more difficult to read, format is beneficial to him and maybe to some others that might be writing these tests. But the compromise might be just to have a parser that turns that into JSON or some other format. I guess I lean in that direction. The JSON tests are easily readable and thus more easily auditable by the people who didn't write it. I know Preston had some thoughts on this, and Preston and I, we can talk about some of that slot stuff right now or offline, but we can talk about the format first.
Yeah, I think the slot conversation maybe we can do offline, but I sort of agree with what you just said. This like language that Vitalik proposes, at first quite bizarre, and it's kind of like you really need to think about it to just try to like parse it in your mind, like what is actually going on here. And it just makes like, when I first saw this, I thought, like, is this what we're going to be ingesting in our tests? And then like trying to build a test out of that. So maybe that was like the wrong assumption, because, what we landed on now is that, okay, you can use, Vitalik's proposal to create the test data. Like it's, how we derive the data is like, doesn't really matter. You could have, maybe you could have a GUI, or you could use this thing that Vitalik proposed, like whatever. If, so if we go with like a JSON sort of standard where like we don't need to build a language specific parser for this data, then, it kind of makes things a lot easier. A lot of the back and forth, I think, was, in our discussion is maybe I'm misunderstanding like what we're actually testing. From the initial example, we had like some like scenario of what the blockchain looks like and what the different forks look like, and then we wanted to decide like what the final head would be, like given all this data. So I was a little bit confused, like why we needed references to other slots and things like that. Like I just didn't understand why some of that functionality is there. So maybe if you want to, or if somebody can give like a high level of what are the goals of this test, and like what are we hoping to achieve? Yeah, so
the goals are, what is the head, what is the most recent justified block, and what is the most recent finalized block. At its core, this is a fork choice and finality test that brings in the particular construction of the beacon chain along with this epicless Casper. So important to note, and why this notion of slots is important, is because when I make an attestation for a block at some slot, I'm casting an FFG vote on that block and any of its ancestor blocks that are in the previous cycle length slots. And so you can have gaps in slots where there might not be a block for a given slot in a chain, and so you have to have this notion of slots being skipped to really capture the full breadth of what can happen in these fork choices. Because I might make an attestation of a block at height at slot n, and it might only cast votes for 5 blocks because there might be so many empty slots. So that combined with these, I know we've talked a little bit about whether RNG has really any use here, and I don't think it does. It's more a matter of we divide validators into certain slots. And so when I say validators 0 through 9 attest to slot N, I'm not saying validators in this test, I'm not saying validators 0 through 9 from the global set. I'm saying the subset of validators that can attest to that slot. And so for the test writer, they don't have to think about, is that validator with the index 10 through 11, or 10 through 19, or is it the validators with index 20 through 29? They just think about, starting the indexing at that subset of validators, which is a committee for that slot. So that's kind of the general motivations. We can talk a little bit more about that offline. I'm definitely leaning in the direction of we have this easily writable format. We can make a Python script that outputs some JSON, and we as a community can come around a JSON standard that can serve for a global set of tests.
A quick question on the tester selection for slots. When you're specifying, validator 0 through 9 for that selected slot, how do we know what the global index of validators are actually being selected, and how do we keep that consistent across different testing implementations? So because in this testing link, at least currently, there is no notion of these are all equal weighted validators. It doesn't really matter. So you can have your shuffling as being non-shuffled. So you just slice your validator set and apply them to your slots accordingly. The 0th flight goes to the 0th slot. You slice it by the cycle length with whatever shuffling you choose. Shuffling likely will reset on these dynasty changes, but we don't have that currently spec'd, and that even if you reshuffled, still the shuffling doesn't really matter in the context of this test because do you think it would be a problem if the scenarios would be different either on each test run or for each client if they're not selecting the same global indexes? It will not matter as long as those validators have the same weight. It matters that you keep them where you put them, right? So if you're not reshuffling them in between, blocks or slots. But because these are all equal weight validators, you just need to know that, whatever the 0th validator means locally, that the 0th validator voted from the global set. So you need to, when you're summing up votes, you do have to think about the global validators, but you don't care who they are as long as you're not moving them around. Does that make sense? A lot of this is simplified by the fact that everyone's equal weight.
One thing regarding the testing language, currently there are two issues, one in the Ethereum Beacon Chain repo and one in the Prismatic Lab repos. Just to make sure, should the discussion go into the Prismatic Lab repo? Because in the last two responses by Vitalik and Preston were there. And second thing, the only issue I have with JSON is that it doesn't support comments, and I think it's important for research and to comment in or out quickly tests that the testing lang support comments. So of parsable text format, I think either 2ML or YAML are also good. And they have very wide language support.
Yeah, I agree with that. I guess that's why I was leaning towards protobuf text format, but protobuf text format's actually pretty awful to write and read. So YAML or something similar would be ideal.
Yeah, I agree. Go on.
Yes, sorry.
I agree, and that comments are very worthwhile. So YAML or one of these others probably makes more sense. Mikhail?
I just wanted to say that Danny just mentioned that it would be convenient to write maybe a Python script or just to read that language, and so we can add an output in any formats like JSON, YAML, maybe something else. So yeah.
Right, but I think we want to come up with a standard, because sooner rather than later we're going to have a shared test suite, and so we want to have a standard format that we're all comfortable reading from.
Okay, I see, but I don't see any problems with having two formats. Like, but anyway, it doesn't matter, YAML or JSON, as for me. So,
yeah.
Okay.
And in terms of where the conversation, I think we'll probably be. I'll probably be talking on the Prismatic one just because that's where we've been conducting some of the conversations. So follow that one, and we'll try to hone in on some of these decisions next week or so. Cool. Let me see what is next. Cool. There's been a lot of questions on V2.1 around some of the stuff around attestations and some stuff around shuffling, and we've talked a lot on the Gitter, so we might not have some stuff to talk about right now. But if anyone has just like general questions on V2.1 that have come up that you want to discuss in person, now's a good time.
Yeah, I had a question when I was thinking about this the other day. Just about, so say you have a scenario, right, where you have you got a cycle length of 10. So you're at block 40, you're redoing your crystallized state. You look at your shuffling. When you do your shuffling, does that apply to blocks, say like 40 to 49, or does that apply to blocks 50 from 59? I guess another way to ask it is there like a look ahead here?
Currently, the shuffling's not handled in the spec at all, so nothing's reshuffled because the validators aren't changing, and we're just not handling the RNG. Reshuffling is likely going to occur on some multiple of cycle lengths. So that's a dynasty change. Is when you do some of these more you do dynasty changes. It's kind of a subset or extra stuff on a state update. And dynasty changes when you bring some new validators in and out. It's also when you do recompute shuffling and some other stuff. So some multiple of cycle lengths, and if finalization has occurred, then likely that will be the trigger for a reshuffling. And at that point, yeah, you'd immediately have your reshuffling, because you're ready to move. You've finalized and you've brought in new people. You've now have kind of this notion of a new validator set, although you still have some overlap, still have majority overlap. But you have this notion of like, here's our new validator set. What's our shuffling? Let's begin finalizing stuff.
Okay, thanks.
This is Terrence from Prismatic Lab. I have a question regarding if, let's say, you receive an incoming block, and let's say if there's a few bad attestation that's within the block, what do you do with the block? Do you just like ignore the block?
Bad attestations in what respect? Malformatted?
Let's say that's probably just a bad signature or like
yeah, that's an invalid block and should be discarded.
Okay, I see.
Yeah, like if they bad.
I mean, if you have a bad signature.
What was that?
Oh, go ahead.
Oh no, I think you're about to say there isn't actually a signature within that block, so they might not. Yeah, so the attestations might have a bad signature, or you might not be able to verify the signature, but they also might be, maybe they include attestations for a slot in the future or something like that. What were you going to say, Justin?
I was going to say, if you have one of the votes with a bad signature, then it's going to pollute the whole aggregated signature. So if you have 1,000 people voting and even just one bad signature, then the whole signature is going to fail. So it doesn't really make sense to have a single signature, which is wrong.
Well, but a single attestation could fail the signature. So the block producer should have known that and not included it and not broadcast it, unless they were trying to spam or something like that. But it's like having someone produce a proof of work block that didn't have an acceptable difficulty. Like, it's discarded.
Okay. Got it.
Cool.
I mean, that is that needs to be considered from a denial of service point of view, because proof of work is very easy to check, whereas these signatures might be more heavy. And so if you have multiple signatures per block and just the last one is invalid, then it's possible that you spend some time checking everything, and then at the very end have something failing.
Basically, proof of work is not so easy to check if you don't have a pre-calculated data set. I mean that it takes time to calculate data set and check the block. And it's
right.
Not a little amount of time.
In the sense that you could have a correct proof of work, but you could have bad data at the end of the calculation. Like bad transaction data. Okay.
Yeah, I see. Yep.
Yeah, just
I mean the proof of work. For example, if hash is not so, like, it's much easier to validate a transaction than validate a block in terms of calculations. So I don't have a numbers of BLS signature verification or attestation verification, but I think that should compare to proof of work verification. If we calculate, if we take into account that it takes time to calculate the data set.
So BLS signature verification should take on the order of milliseconds, like 2-3 milliseconds, that kind of thing. And so if you have 64 crosslinks, or then just multiply that by a few milliseconds. It's possible if you use multiple cores that will go down, but yeah, maybe 100 milliseconds is like the worst case.
So Justin, we talked about a Dfinity style zero knowledge proofs to be privileged actors in the network a little bit last week as one way to mitigate kind of add DOS protection. I know you were the one that had originally told me about that. Do you have any thoughts on that? I was meaning to dig in a little bit the last 2 weeks, and I did not have time to do that.
Yeah, I mean, I learned about it through by going to a Dfinity meetup, and from what I understand, they're actually going to write a white paper specific on the peer-to-peer networking. And it seems that Dfinity has done a lot of innovation on the peer-to-peer networking. So not only have they written their peer-to-peer library from scratch, not using libp2p or IPFS in any way, they also have, as I understand, these zero knowledge proofs to prove that you're a privileged actor. But I think they're also innovating on network relay policies and topologies and stuff like that. So at this point I'm mostly speculating, but as I understand, they want to release 7 or 8 white papers, and they've only released one right now on the consensus. And as I understand, also the next one will be on the peer-to-peer networking. So I guess keep an eye out for that.
Cool. Any other V21 questions?
guess just going back to what Terence was asking before, I guess say you get like halfway through the attestations of a block and you find an invalid one, it's probably worth hanging on to the other attestations that you did find in that block, though. Would you agree, Danny?
If you haven't seen them yet and they're valid, they're probably worth putting in your database to add to your fork choice rule and for potential inclusion if you're a proposer.
Cool.
You know, you would likely be seeing these attestations be coming in outside of blocks, but that might be a worthwhile optimization, depending on what we start seeing in the wild.
Thank you.
Cool. The next thing we have is practical details of random beacon and committee selection. Nakara, you proposed that, right? Can you give us some thoughts on what you were thinking?
So right now we've been mainly focusing our discussion on P2P serialization and how the P2P layer will look like, which I think ties into this a little. So given that we kind of know a little bit what that looks like, what would how would the nodes actually come to agreement on the random number? So I know that they're using, that Justin had proposed in a different talk, using RANDAO and then inserting the results of the RANDAO into VDF. So I was just wondering how would that look like in practice from an implementation point of view? And community selection is because the spec mentions committees but has no details on how that would work. My initial thoughts on community selection are that using the random number from the beacon, we could potentially use that as a seed into some random sampling method and then randomly sample nodes for community selection. Those are my initial thoughts for now. Does anybody have any input?
I'll answer the second part, and then Justin can answer the first part. So the second part, we have this field in crystallized states called indices for slots. It's an array of arrays. And so it's the length, cycle length, or it might be cycle length. No, I think it's cycle length. And so you have an array for each slot, and that array is a shard and committee, an array of shard and committee objects. And so a shard and committee object has the committee inside of it. And this is all an output of get new shuffling, which currently is only used, I think, at the beginning to seed this entire thing, but would be used on the dynasty changes and when you have a new RNG. So the get new shuffling shuffles validators and also puts them into committees. And committees are are assigned to certain slot heights and are assigned to certain shards. And so it is happening in this spec. And so take a look at get new shuffling and take a look at shard and committee objects, and they all get placed into the indices for slots array. That said, we're not really doing much. We're not really doing reshuffling at the time in the spec. We're just kind of doing an initial shuffling and placing people statically. If Justin wants to give some more concrete details on what like a RANDAO plus VDF would look like in production.
Right. So I actually linked to some slides I prepared VDF day. And there's some diagrams there which might clarify what's going on. So basically you have the RANDAO reveal period, and that's pretty standard in the sense that at every slot you have a block producer, and it creates a block which gets included on chain. Then that block will also have a RANDAO reveal. And then once you get at the end of a certain epoch, let's call it an epoch, let's say 100 slots, then you XOR all the reveals, and then you get your RANDAO number. And that RANDAO number that is like a weak source of entropy in the sense that it could be biased by some of the last revealers, some of the last basically block producers. And then you take that random output and you feed it as an input to the VDF. And then basically there's several things going on. So if you look at, for example, slide 11, there's going to be this notion of a target delay. So the protocol is going to have a difficulty adjustment scheme, which goes up and down according to the performance of the network. And the target delay is going to be what the difficulty targets. So let's say that's going to be 10 minutes. And at some point, the block producer, some block producer somewhere is going to find the output of the VDF with a proof that it is the correct output, and he's going to include that on-chain. And when this on-chain inclusion happens, it either happens before the target delay or after the target delay, and the difficulty is adjusted accordingly. So, in terms of practical things to consider, we need to put a bound on how long the VDF evaluation could take. So even though we're targeting 10 minutes, it's possible that in the worst case scenario, it could take 20 minutes or 30 minutes. And so that's something to take into account. And then another thing to take into account is when it is, revealed off-chain, broadcasted and gossiped to the whole network, it still needs to be included on-chain. And so we have the notion of an inclusion buffer on slide 13. And that those are most of the practical considerations from implementation. It is a fairly simple protocol. I guess some of the subtleties that you want to understand is from a protocol designer point of view. One of the questions is how long should the evaluation period? What is the worst case evaluation period? And it turns out that it's on the order of a squared, where a is like the maximal advantage that an attacker can have. And the reason is that if an attacker ramps up the difficulty with hardware which is, let's say, twice as fast to everyone else, then because to prevent grinding, you have your evaluation period needs to be at least on the order of A, and if the attacker suddenly goes offline, then everyone needs to catch up, and they're 8 times slower, so you get a factor of A squared, that kind of thing. On slide 16, I have how the incentivization works with the idea of having 2 parallel VDFs, one on the public seed and the second one on the public seed XORed with the public key, and that gives you a way to basically incentivize, attach the VDF to a specific public key which can't be stolen. The thing is that we probably have a better construction for this now. This is something that I mentioned, that happened during this research event, where we found a way to do so-called watermarking, where you in the proof of the primary VDF, you kind of construct a special proof which is linked to a specific public key.
Right. So from a implementer's perspective, there's going to be some details added to the spec that are there'll be probably another field in a block where people can include a VDF output. There will be some rules around assessing whether the VDF output is valid, like if it's from the correct cycle or epoch, and whether it has whether it's satisfying a solution to the expected input, which would be some of the RANDAL XORs, and then plus that that when an output is included in a block, that can serve as a seed of randomness, and there will be rules around which seed of randomness and when to use that seed of randomness to reshuffle things. you know, and then there's a couple of things on recalculating difficulty, but that's more of that's and what you know, recalculating difficulty for future videos. So not terribly complicated, kind of like handling attestations, but on just rarely handling this like extra input to blocks and validity around that, and then exposing it to the other part of your processes that need the RNG. The next thing on the list is practical VDF implementations. I think Justin kind of handled that in his research update, talking about the two primary ones with the RSA moduli. Are there any other questions around that right now?
Not really. Is there any results from the VDF meetup that are public, are being made public?
So the main set of results are actually relevant to Benjamin Witolowski's paper, and Benjamin told me that he was going to update his paper, which is on ePrint. And it's possible he's already done it. I haven't checked, but I expect it to be some sort of appendix to his paper.
Cool. If you can check or share the link, that would be helpful.
Yeah, I'll share the link right now.
Cool. The next thing is discussion of some of the cross-shard communication proposals, asynchronous and synchronous. Maybe Casey wants to give us an update on maybe the recent proposal from Vitalik. I know you're on that thread.
Yeah, sure. Yeah, it was a really nice post from Vitalik on my favorite topic. There's still two main issues. I feel like one I think we have a good answer to, which is, so the first concern is usually when people propose synchronous cross-shard, a synchronous cross-shard transaction protocol, the concern has been that the state execution gadget won't be able to keep up if there's, you know, too much, if it requires too much network communication and too much latency, then state execution can't keep up with the block proposals happening at the data layer. But the second issue that I'm worrying about, which I left a question in the thread, I guess it doesn't have to do even strictly with cross-shard transactions, but even just the phase one, a naive phase one design itself treats data blobs as just generic, so they don't, you know, contain any transactions, and there's no distinguishing between if data blobs have any useful data or if they're just junk. So, you know, what I'm wondering about is if in the naive phase one design, is it considered a problem if validators who are proposing blocks just stuff the data with junk? If you get my question.
Yeah, I don't know if I know the answer. Xiaowei, I know, has thought more about blobs than I. Do you have any thoughts, Xiaowei?
Well, I think, yes, it's possible that the block will be full of junk. But I know the application that Vitalik might want most is the decentralized Twitter. That kind of application could be run on the phase one sharding chains. But yeah, so far the phase one application might be very limited.
So Casey, but isn't that the kind of the point, is that it can just be filled with junk and that there's no structure?
Well, the problem that comes is then, how do you, if validators, malicious validators could stuff it with junk, and there would be no room left for anything useful like tweets or transactions or plasma data or anything. I mean, if validators can just stuff it with junk, then what disincentivizes validators, or what incentivizes validators to include useful data?
But isn't the move, when you do formalize the execution layer, the move is to move to more structured blocks? This is a little bit out of the scope of what I'm my understanding of the phases. So my understanding was that you have data blobs at the beginning and then move to more structured blocks as you formalize the execution layer in phase 2 or 3 or whatever phase.
Yeah, I guess from my perspective, the problem is that I mean, it's an easy, it's easy to design a protocol, an execution protocol, if you assume that the data blobs are useful. But it gets harder if you allow, if it's possible for validators to stuff the shard blocks with spam, useless data blobs, and it's not clear how much of a problem that is, or what ways there are to prevent that from happening.
Right. I remember seeing something somewhere, the notion of maybe flagging blobs as to, when we add execution layer, flagging blobs with a bit to say whether they're just data or whether they're part of the transaction execution layer. Again, I've read some stuff about this, but it's not something that's in the forefront of my mind, so I'm not 100% sure.
So from the point of view of sharding phase 1, I think we want every block to be the same size. And so in that sense, every single block will be 100% filled with junk. And by filled with junk, I mean that, they will not be interpreted by the EVM once we launch the EVM. So everything will be ignored. And what goes into the blocks is ignored until we launch the EVM, and then when we do launch the EVM, only the new blocks will be interpreted for state. So in that sense, it will be 100% junk. In terms of what disincentivizes proposers from just filling the blocks with junk, well, it's the exact same answer as with Bitcoin and Ethereum. It's like opportunity cost on lost revenue from the execution fees and the gas. Now, I guess it maybe the question is, what is the gas mechanism prior to having an EVM? Well, it is possible that you can have out-of-band fees to incentivize the inclusion of things. So, you could imagine, for example, a plasma chain for which you can pay the next proposer to include a tweet, and that payment would happen through the plasma chain. So even though there's no concept of gas, and from the point of view of the EVM, it's all junk, you have achieved something useful.
Okay, then. So it sounds like everything's just up in the air still, which is yeah, what I thought. So that's good to know.
So, but when you add an execution layer, when you add a VM, you do move to the notion of like block validity in terms of the VM. So even if you do have some of the block, you can carve out some of the block for data and rather than transactions. If you have a portion of the block that's carved out for the VM, it has to conform to the VM rules or VM validity, right? Or else the block will be discarded if there's an enshrined VM.
so no blocks will, well, only unavailable blocks are discarded. So by unavailable, I mean a block for which, you know, there's, well, basically I mean basically a block header for which there's no block body which hashes to the block header, and the block body needs to be of the exact right size. So let's say 100 kilobytes. And if your block is available, then it will be valid. What might not be valid is going to be the blobs inside. But there's no way to, you know, that's part of the effort that we've put into the blob serialization, is that every block will serialize, you know, deterministically and without exception, without throwing an error, to a list of blobs. And then once the EVM is implemented, then some of these blobs will become transactions and run in the default execution engine. But of course, you know, one of the things that was mentioned in Vitalik's blog post is the idea of an alternative execution engine, or a layer 2 execution engine. And in that respect, the blobs don't need to convert it to transactions. They can convert into so-called out transactions, which, you know, from the point of view of the default execution engine are junk, but actually they provide real value for the user. And, you know, this alternative execution engine would come with its own incentivization scheme.
Cool. So there is a clean separation between phase 1 and the phase 1 data layer and the phase 2 execution layer. So phase 1 has no gas rewards. It only has block rewards, but no transaction fee or gas mechanics. So the incentive for proposing blocks is to earn a block reward, but not necessarily a gas fee.
Yeah, so if you talk about, strictly speaking, layer 1 in terms of enshrined infrastructure, that's absolutely correct. And that's something, you know, that's one part of the design that just hasn't changed for months, like over 6 months, or even like close to a year. It's been like that, a very clean separation between layer 1 and layer 2. Yeah. But, you know, even though there's no layer 1 incentivization scheme, you definitely can have layer 2 incentivization schemes. And in which case, it would be against rational proposers to, you know, have blocks which are all zeros, for example.
Yeah, I suppose it's the same level of freedom for validators or block proposers as with the current Ethereum, because they can, you know, there's nothing that stops validators from proposing empty blocks or from including a bunch of transactions that have a gas price of 0. So yeah, it seems it's essentially the same level of freedom in terms of what data blobs or what transactions they can include.
Yeah, it's the same.
Cool. And there's
Okay,
a lot. Oh, go on.
No, I just said thanks.
All right, cool. Yeah, there's a lot more around cross-shard communication. I'm going to table the rest of the potential conversation for now, and, you know, ask questions on the getter, and we can bring it up next time. It's a little bit, you know, we have some people like Casey who are thinking about this a lot, but in terms of practical beacon chain implementation, it's a little bit, you know, in the future. The next question, the next potential topic was talking about proof of custody implementation and whether that part of the spec has been finalized. And I think I noticed in some of the channels there was maybe a little bit of confusion about the proof of custody and what it's in relation to. In terms of the beacon chain, just the beacon chain, not the shard chains, there's no notion of proof of custody. Proof of custody comes in with the building of the shard chain. But I think Terrence brought that up. Do you have further questions or thoughts?
Yeah, I'm
Justin's a
wondering,
local expert on that.
because from the research perspective, I've seen a few research threads that's floating around, but from the spec wise, I haven't seen that much finalized spec in terms of proof of custody. So I'm wondering, is it because we haven't started really messing around with the shard chain yet? That's why there hasn't been like a spec on it?
Yes, that's my understanding.
Yeah, I mean, I should just sit down and try to spec it. One of the nice things is that from a research perspective, there isn't that much more we want to go into. So, the 1-bit custody scheme is it's optimal. It feels optimal. I can't necessarily prove it, but I don't see how it could be improved, at least in terms of the overhead to the beacon chain. One area where there is some kind of ambiguity as to how it could be implemented is in the challenge game. My philosophy there is it doesn't matter if the challenge game is suboptimal, in the sense that the messages are slightly longer, or there's slightly more rounds, or the reason is that the mere existence of this challenge mechanism should disincentivize anyone from putting in incorrect custody bits. And the reason is that you stand to win almost nothing. You save a little bit of bandwidth and a little bit of computation by putting the custody bit at random, but you stand to lose 32 ETH by putting a wrong custody bit. So my philosophy is just to have a challenge game which is based on a single challenge message and a single response message, and try and keep it as simple as possible, simply because I don't expect it to be triggered very often. And other than the details of the challenge game, there's a question around which hash function do we want to use for the merkleization, and it's still up in the air what we want to use here. One of the main questions is, do we want to use a stock-friendly function, and if so, which one? I am personally a proponent of having a stock-friendly function, and one of we'll have two candidates. One is called Mimic, MIMC, and the other one is based on AES. But Starkware, who we've given a very large grant, will be producing a report fairly soon and making it public, and encouraging feedback on that report, where they will make suggestions as to what would be stock-friendly hash functions, and at that point, I think we'll be able to make a decision. There's also some parameterization around how long the challenge periods should last, and how long the secrecy period should last. How long you should keep your secret, and that kind of thing. But these are mainly parameterizations. They don't really affect the design that much.
And in terms of the beacon chain spec, there's no stubs currently for the individual validators proof of custody or for the slashing conditions. They're just noted at the bottom. But either before we launch the initial version, we would at least have stubs there, or we would put them in, on some subsequent fork.
Yeah, I mean, if we do have a custody bit, it would make sense to just set it to 0 all the time until we actually have shard data.
Right, kind of
So
like how we're going to have some set hash or function to hash for the shard block hash in the crosslinks currently.
Right.
Very cool. The last thing, so I don't think I got a response from everyone, but in some of my discussions, it started to seem like the 26th was kind of an unreasonable ask to get people to Prague early, as DevCon starts the 30th. I am looking into whether we can secure a space on the 29th rather, for like a good chunk of the day, starting in the morning through the mid-afternoon. That would be around the conference center, and so I think it would be a little bit more reasonable in terms of getting people there. I know there's some conflict with status, but I hope that they can still have some representation. Not finalized yet, but I'm gonna check into that, and hopefully on Monday I can give you an answer whether we're going to be doing Monday, Tuesday, whether we're going to be doing a meetup on the 29th. Cool. Anything else anybody wants to talk about before we close this meeting? We have a few minutes left.
I'd just like to note that I'm still not really happy with the proof of custody from the decentralized staking pool's point of view, but you guys are pretty familiar with that, so yeah.
Right.
Can you remind us?
So my issue with it is that I don't see a mechanism that allows you to distribute this secret among the people, or some way that you can, in a trustless manner, allow no single person to have access to the entire secret, which allows you to compromise everyone's, or basically everyone in the pool slashed. And you can't really compute any of this stuff anyways. By multi-part computation, you can't compute the Merkle tree between all of the nodes.
I see. Any proposed solution?
Nothing off the top of my head, at least.
I mean, there was one issue around, the hash chain and the hash onion, where that's difficult to do in the pooled context. I think the solution there is just to forget about the hash onion and have separate commitments and reveals there, and then in terms of building the proof of custody with all the hashing, this. Right. So, are you saying that it right? No.
So one thing for if the degree to which you get slashed is minimal for exposing your secret in the proof of custody. If it's minimal or just relatively small, then I can, internal to my pool, assign basically every pool member that they have a different secret for whatever time. And if your secret is exposed before the appointed time, I can punish that individual within my pool, provided that individual share greater than the punishment that will be received. And I assume it's some polynomial of the number of people being punished at a given time. But if it's on average, the order of that is relatively small, then that places a size limit on the amount of ether each person in the pool.
Right. Yeah. I need to think about it more. I don't have a solution. right?
Cool, thanks. Just to keep thinking about it is, yeah.
All right, cool guys. We're at the hour-and-a-half mark. Generally, I think really productive meeting. Stay in touch on the Getter, ask questions. I know there's been kind of a really good, lively discussion recently, and we'll hone in on some of these details that we discussed over the next couple weeks. Thank you. So the core dev calls got a little bit off. They did a meeting last week, and they're doing a meeting this week. So they're doing a meeting tomorrow. I don't think we have a ton of overlap in the members of the people that attend both meetings. But before I schedule when this call is going to be, I'm going to wait and see what the core dev call does tomorrow, whether it's going to do like another meeting next week or whatever, and we'll try to plan around that. But I'll early next week I'll have the call scheduled for when the next one is. Really appreciate everyone coming out. Thank you.
Thanks, everybody.
Thank you. Bye.
Bye, guys.
Thank you.
Thank you.
Thank you. Bye-bye.
Bye-bye.
Thank